Hello everyone, you are welcome to this channel. Today we shall be looking at how to perform reactor design using conversion. In the last episode, we look at the design equation for different reactor. So like batch, CSTR, plug flow, as well as the packed bed reactor. So we look at their design equation in the last episode. Like that of the batch reactor, we have the Na dt equals to RAV. So this is in terms of mole of the species A. So, but it is often desirable to have it as in form of conversion. So the other reactors, they also have their own design equation. Like this is for the CSTR, it's in algebraic form. Fa naught V is equal to Fa naught minus Fa over minus Ra. For the plug flow reactor, it has its own design equation in differential as well as integral form, as well as packed bed reactor. But today we are looking at the how to use the conversion X instead of the mole N. So let's see an example. For a batch system where we put a species A, the mole A of a species into it, the initial one you put into it is Na naught. And after reaction has taken place, let's say A has converted to B, that means we have Na left. Na left. So how much of Na naught has reacted is X. X of Na naught has reacted. Therefore, the Na that is remaining is equal to Na naught minus Na naught XA. So X is what? Is the conversion term. That is maybe 50% conversion, 60, 70, or even 100% conversion. So that will give us our remaining mole of A. So if you factorize this, we are going to have 1 minus XA into this. Therefore, we can use our Na is equal to Na naught 1 minus XA. So if we go back to the design equation for batch, the Na dt equals to RAV. So in this Na, we can put our Na naught minus XA into it. So in order to get it in terms of conversion. So therefore, the Na dt equals to RAV, and the Na naught 1 minus XA dt equals to RAV. So if you differentiate this, it's going to give us Na naught or minus Na naught dxa. So dx dt equals to RAV. So we can simplify it or rearrange it to add Na naught dx dt equals to minus RAV. So that means we have turned the design equation for batch from Na to dx. Instead of dna, it's now in terms of dx, in terms of conversion. For other reactor types, we also have their conversion term instead of Fa. So this is Fa naught for the CSTR, Fa naught X over this for plug flow reactor, as well as for the packed bed reactor. So they are all in terms of X now instead of Na, Fa before. See, they are all in terms of X now. So that means we have changed the design equation into conversion term. So let's look at an example. In this example, we have isothermal gas decomposition reaction. A convert to B and C. So the entry condition is that the volumetric flow rate of A is 6 dm³ per second, and the total pressure is 10 atmosphere. The molar fraction of A is 0.5 and the temperature was what? 422.2 Kelvin. Now, something was mentioned here. The initial charge into the reactor was an equivalent mixture of A and inert. What does that mean? It means that what? When A is fed into the reactor, there is an inert too that also comes into the reactor. So inert comes here and A comes here. And the molar fraction of A was 0.5. That means inert was also 0.5. So please take note of that. So what is the question? The question is that calculate the volume necessary to achieve 80% conversion in a CSTR. So let's see. Now, they also give us a table here. So the laboratory measurement given in table below show the chemical reaction rate as a function of conversion. So this is the table they refer to. So they give us conversion and the reaction rate there. The reaction rate is given as minus RA as well as the inverse or reciprocal of that, 1 over minus RA. So 10% conversion, this is the RA. 20% conversion, this is the RA. 30 and so on, up to 85% conversion. Now, let's see how to do this. They ask us to do what? To calculate the volume of the CSTR for 80% conversion. So, what is the equation? V is equal to FA naught minus FA over minus RA in terms of FA. But in terms of conversion, V is equal to FA naught X over minus RA. So, that is in terms of conversion. So we are going to use the one in terms of conversion because that is the table gives us conversion term. So, but to do that, we need to calculate our FA naught. We already know X at 80% conversion is what? 0.00125. So then we already know our RA there. We already know X. So we need FA naught. So how do we calculate FA naught? You remember FA naught is equal to CA naught times V naught. So CA naught is molar concentration, while the V naught is the volumetric concentration. Volumetric flow rate. So always be conscious of the unit or the dimensional consistency of whatever you are doing here. This is mole per second. This one is mole per meter cube or dm cube. And this is meter cube or dm cube per second. So dm cube cut, so we have mole per second. So we were given V naught. What is V naught? Which is the volumetric flow rate, is 6 dm cube per second. But we don't know CA naught. So we have to calculate our CA naught from our gas equation. You remember PV is equal to nRT, and what is this is, it may P over RT is equal to N over V. This N over V is CA because it's mole per dm cube. Mole per dm cube. So this is CA. So we are going to use this to calculate our CA naught. So how do we do that? CA naught equals to P naught YA naught. We have to multiply the PA naught by YA naught. Why? Because the molar fraction of A is 0.5. So it's not totally completely A. So A is there, inert is there. So the molar fraction of A is 0.5. So we have to multiply the total pressure by that. Divided by R, 8.314, and the temperature, which is 422.2 Kelvin. So remember all those from the question. 422.2 Kelvin. So once we know all this, we can now calculate our CA naught. So therefore, after we get our CA naught, we can then get our FA naught. So FA naught is now equal to CA naught times V naught, which is now equal to YA naught P naught over RT times V naught. So when you substitute into all this, you remember this is 0.5 times 10 divided by 8.314 times 422.2 multiplied by 6. So everything will give us 0.867. So that is mole per second for our FA naught. So now that we know the FA naught, we are now left to get the volume that we are asked to calculate. What is the volume? V equals to FA naught X divided by minus RA. So what is FA naught? 0.867. What is our X? 0.8. Because we are asked to calculate the Earth at 80% conversion. So which is this one. So then what is our minus RA at 0.8 is 0.00125. 0.00125. So with that, our volume is obtained as what? 554.9 dmq. So thank you, and please hit the subscribe button at the bottom of this page, as well as write any comment that you may want me to respond to. Thank you.